We are live. Okay, so you ready? 4:24:18, and we're talking today about there are going to be non-right triangles. So they're not right. They are any old regular old triangle, right? They're not right triangles. They're just any old triangles, right? And we always know 180 degrees, but there's no 90-degree angle. Okay. So today what I want to talk about specifically is the thing called the law of sines, okay? So before we do anything, I just need you to draw a triangle here off to the side. Try not to draw it in such a way that it looks like an equilateral. Okay, try not to draw it as an equilateral or a right. Okay, so I'm just going to try and draw any old triangle. Okay, there's my triangle. And then what we want to do is this. I'm going to put some things in here, okay? So there's no longer a hypotenuse, okay? No hypotenuse, right? There's no hypotenuse because you don't have a right angle. Makes sense? So if that's the case, let's call this an angle theta, okay? So we got theta 1. So that's my first angle. And let's call this angle here theta 2. So I have two angles. Maybe it's, 30 degrees, and maybe it's 80. Maybe it's 40, and maybe it's 75, but two different angles, right? So since we don't have a hypotenuse, we have opposite sides, right? So from this angle, this side would be its opposite. So let's call that opposite 1. And from this angle here, it has an opposite. This would be its opposite 2, okay? So we could still have adjacent sides, right? So you could still have adjacents. But if we wanted the area of a triangle, area is equal to 1/2. And we're going to go adjacent 1 times adjacent 2 times the sine of the angle, okay? Well, let's draw another triangle down below. And if I have a angle, right, and again there's no hypotenuse, right, then these two would be the two sides next to it, right? So that would be my adjacent, and that could be my other adjacent. Now it doesn't really matter which one you call adjacent 1 or adjacent 2, but it's the two sides next to it. Adjacent means next to it, okay? So we're going to use this figure to find the area, okay? We use this figure to find the area. Some people just throw some numbers in, and let's go ahead and figure out how easy this is. Super easy. You don't need to know the height. If you know, for example, as an example, if I said this side was 10 centimeters, let's say I say as an example this side is 8 centimeters. Let's say my angle happens to be 48 degrees, okay, just as my example. Then the area of this triangle is as simple as this. Area is equal to 1/2 times 10 times 8 times the sine of 48 degrees. Okay, that's all it is. So the formula says 1/2 adjacent, that's 10, times adjacent, that's 8, times the sine of the angle. And it doesn't matter if the 10 or 8 are switched around because they're both adjacents, right? It doesn't matter. So then I'm just going to use my calculator to get the answer to this. So I'm going to go 1/2 times 10 times 8 times the sine of 48, and I get an answer of 27 or 29.7. That's it. 29.7, we'll say centimeters squared. So it's kind of cool because you have a formula now where you don't need to know the height. And normally it's 1/2 base times height, but you don't know the height of this triangle, right? But you don't need to know it. If you've got these two sides and that angle, so you need the angle and the two sides next to it, it's just 1/2 that times the sine of 48. Thumbs up? Does that seem pretty easy? Okay, now, the law of sines. Let's go back up to this triangle, okay? The law of sines. Let's go back up to this triangle, okay? The law of sines. So we're going to go law of sines. Now there's two law of sines formulas, okay? One is to find the sides. First one is to find a missing side, okay? And I'm going to make a little bit of note here, and hopefully you're going to always follow this, okay? Dave, you could sit over there if you want to, if that's easier for you. You okay? So make a little note here, okay? This is what I do. It's easier for me. I always write the unknown first, okay? And I'll show you what that means when we get to an example, okay? I always write the unknown first, and I'll show you exactly what that means first, okay? So here's the law of sines, okay? So it's going to be, ready? Opposite 1 over the sine of theta 1 equals opposite 2 over the sine of theta 2, okay? So, for example, if I know these two sides, I could set up this side over the sine of its angle would equal this side over the sine of its angle. I'd set up just a little ratio. Whatever this side is, let's say it's 10 over the sine of this angle would equal this side over the sine of this angle. Okay, that's all you do. And then you cross, multiply, and solve. Now, we're going to do these in the notes, okay? The other is to find a missing angle, okay? Okay. So the law of sines has two parts. We're just going to write it just the opposite. We're going to write it instead of opposite over sine, we're going to rewrite this as sine of theta 1 over the opposite 1 equals the sine of theta 2 over the opposite 2. Okay, write that down. And we're going to add one last thing when you get done with that, okay? Okay. So you're going to cross, multiply, and solve. And we're going to do this in our notes. I'm going to show you how this works. The last thing is we're finding a missing angle, so we know you're going to say, hey, Mr. Davies, don't you have to then push the sine inverse button, don't you? Right? So that will be our second step. Whenever we have to find the angle, we always push the inverse button, right? So that'd be our last step, okay? After you cross, multiply, divide, you always do this last because you want to find an angle. We always push the inverse button to find the angle, okay? To find an angle, okay? Let me stop the reading right now, and then we'll record the next piece, which is going to be the